Hello code fans, this is the Code Whisperer here. In this clip we are going to make an animated fractal. To be honest, I don't know much about fractals or how they work, and full disclosure, I'm basing most of what I'm doing on this tutorial available here at this URL, which I just read 20 minutes ago. So we're going to get started right now making this fractal animation. It'll look like this. Whoa. So here we are in our big ol' code base. First, let's add a canvas since we'll be drawing the canvas full of fractaliness. There's a canvas, that's looking good. All right, so in the JavaScript, let's get our canvas. Can we just say canvas? Is that going to return the right element? No, we got to get its ID. So let's give that an ID actually. Then in the JavaScript, we'll say let canvas equal document.getElementById my canvas, and we'll let context equal, we'll get a context from the canvas, canvas.getContext 2D. So it's a 2D kind of thing. You can make 3D images, like even a 3D fractal in a canvas, but Lord, if we don't know how to do that. So we got our context. Now what's going to happen to draw our fractal is we're going to loop twice. We're going to do a for loop for 200 steps and another for loop for 200 steps. And a bunch of stuff that I don't understand yet is going to happen right there. So let's do it. Say for y equals 0, y is less than 200, and we'll increment y. We'll do a bunch of stuff. Then within this loop, we'll make another loop that does the same thing, but it's for x. So I think what we're doing is we're looping through a 200 pixel by 200 pixel image, and it really could be anything. And the code almost crashed when I did that, but then it didn't. So somehow, we're going to go through this loop and we're going to figure out what the value is for a whole bunch of different pixels. So we'll define two variables, cx and cy. And cx will be equal to -2 plus x over 50. Why? I don't know. I don't know what cx is. We're just going to have to find it. We'll see what it does. And then we have cy, which is the same thing, but with y. -2 plus y divided by 50. And now we'll define a variable I. I is going to be the number of steps that we do fractally iterations. The more steps, the better the fractal looks, but the slower it is. So we'll start with, I don't know, 50. We can change this. Or actually, let's define it as a const, so it's easy. Const fractal steps equals 50, and I will be equal to fractal steps. And if we figure out what cx and cy are supposed to do, then we will also do stuff for that. So first we need to do a loop with some big ol' math, but we're actually going to skip that because I kind of want to see what I is even going to be here. So the next thing we're supposed to do is supposed to say I equals I.toString 16. And what the heck is that even supposed to do? God only knows. And what is this? This is inside the for loops? Yes, this is inside the innermost for loop. Let's just console log I. God only knows. And let's also make this down to fewer steps because it's a whole shit ton of steps, which freezes the computer. So I is always 32 if we just take 50 and make it to string 16. What? Why? What is toString dot 15? Let's try that. Hello dot toString 16. It makes hello. What if we do a number? Num equals 50, num dot toString 16. Right, it makes a really weird number, and then that's 62, and that's 302. Right, so this is the radix. This represents the base, and what we're doing is we're taking our I and turning it into a base 16 number, which God even knows what that means. But if you take the number 50 and turn it into a 16-bit number, you get 32, so that's pretty cool. So for each one of these dots, we're going to draw a rectangle in the canvas. Together, the rectangles are going to create the illusion of an image. So inside each of these, we'll say context.beginPath, and then we'll define a rectangle. And for each step, the rectangle is going to be at a different coordinate. So we'll say x times 4, y times 4. So start it out 4 times to the right and 4 times down, or of whatever the value is at this point. And then make them 4 wide and 4 thick. And then we'll make a fill style. And the fill style will be based on I. So the reason why we're changing I is to give it a different color somehow. In this first example, though, what we're going to get is we're going to see them all the same color because we actually haven't operated on Y. Context.fillStyle equals, and let's just do a big ol' template string, hashtag, and then we'll template in I, and then I, and then I. And then we'll fill the shape. So this should result in something. Yes! Here is our little tiny proto-fractal. It's pretty darn cool, although it's just a gray square that doesn't do anything. Good. Good. So the idea here is we want to think of some sort of clever operation to do on I, where the results based on different y's and x's will be different, but only a little bit, and that will change how the picture looks. So to demonstrate, let's change this a little bit. I'll get rid of this console log and make this up to 50/50, so it's just bigger. And let's also just add some classes to my canvas, since I think it should have a bit more height. My canvas, height 500, width 500. Or no, that's just going to make everything all stretched out. I actually forget how this works best. Let's get rid of these canvas decorations for now. My canvas, do we define the heights here? Yeah, I think we do. Height equals 500 pixels, width equals 500 pixels. Now we're cooking. Now we see all our dots. So to demonstrate what's going on, if we go inside this code here and we just give I a random value, I equals math.random times 24. Or actually just make that one number long. Math.floor, math.random times 9. Hey, no way, that's cool. Okay, so by just using random, we've gotten this cool looking noisy square, which in itself is a pretty cool achievement, I think. We made the square of noise just by picking a different random value for each one. There's no logic to this. We're not even using these cx, cy values. I still don't know what they do. Let's put this in a function. Now, if we put a set timeout and we call the function every frame, like I'm going to attempt, once I get this all lined up to my liking, set interval, draw fractal 100. We get the cool looking image. It's like the static for your television. So this actually wasn't, it's not in the plan. We're just doing this for fun. Look at it go, yay! It's a big old square of noise. Now what we want to do is, this noise is great, but we want it to be a bit more logical. We'll just draw fractal once. We're gonna have animation again later. So there's our noise. Now let's get rid of this random part, and instead we're gonna do some math-like calculations on the values cx and cy. So we're going to do a block of code while the following is true. cx times cx, or the square of cx. Oh, great, we crashed it. We crashed CodePen. With a while loop. Still looks good. So get rid of this, and now let's rewrite our block so it doesn't break. We'll just get rid of this draw fractal call so it doesn't get called until we finish writing it. Do this while. So we want the square of cx times cx. And if we take that and we add it to the square of cy, it should be less than 4. And I'll put those in its own little brackets. And then also we want to stop this loop if I is greater than 255. I is going to be our greatest value because these all represent RGB hues. So I'm going to write a bunch of code that the nice man who wrote this article told me to write. I don't know what it means. We're going to try and figure it out while we go along. Now we're going to need two numbers called C-real and C-imaginary. Why? I don't know. But we're gonna make them, and then we'll see if we can changing them changes anything. So we'll make C-real, and C-real should be -0.8. We also need C-imaginary, and C-imaginary is going to be equal to 0.156. Why? Ooh, I don't know. So in this do loop, basically whatever happens in this do loop is going to kind of transform the values of cx and cy. It's going to keep changing them and keep doing until they either get too big or it's done it too many times. And each time it does this step, it'll increment I. So let's put that here, I++. It'll increment y so it changes our hue. So let's define a variable xt, and that's going to be equal to the square of cx minus the square of cy plus the value c-real. Then we'll redefine the value of cy, so it's kind of changing and evolving for each iterative step. And we'll say cy is equal to 2 times cx times cy times c-imaginary. And we'll also redefine cx as equal to xt, which we just defined as being these squares. Wow, this is confusing. Then we'll say I++. Put that all in a big old loop. Make sure there's no errors in our code. That should work. Now let's see what happens if we call draw fractal. We get some weird looking stuff. It's kind of this big ol' off gray thing. That's weird. What if we make it bigger? Let's make it 100 by 100. So yeah, we get this weird pattern of noise. It looks kind of something out of Wolfram Alpha, but obviously we made a mistake in our code since this is supposed to be a big, pretty kind of blossom and not a weird gray thing. So let's change this. We'll, instead of I being fractal steps, we'll make it 0. I don't really know where fractal steps was coming through there. And we're also getting some cool looking, now we're getting a more consistent looking bit of noise. It's definitely freaky what we're drawing, but it's not at all what we had in mind. Let's get rid of fractal steps here. Make sure our code matches the example code. So looping through y, looping through x, we got our cx value, -2 plus x over 50, and then cy is -2 plus y over 50. That's right. I is 0, and then, oh, here we go. So I equals I2 string 16. We don't want to do it here at the top. We want to do it at the bottom after we've done our do while loop. Now what that seems to do is it seems to wash out all but the darkest. So now we get this freaky pattern. It definitely looks fractal. You can see this smooth kind of cool looking gradient, but it's still not at all what we are imagining. Maybe it's because the size is too small. Maybe if the size was way bigger, it would just look right. Nonetheless, let's see what's going on here in our example. So we want to do this loop while the square of cx plus the square of cy is less than 4, but also I is less than 255. Bingo. All right, it says the height here should be 800 by 800, so sure, let's do that. And then let's make these numbers 200 by 200. Maybe that'll just make it look right. No, it's like, okay, that's cool. That's a freaky deaky looking image. Look at what we made, everybody, with math. So we're getting this weird thing. This thing isn't really...
And there's so many TVs, microwaves, radios.
Okay, none of that. Let's close Rick and Morty. It does not look like this. This is not what it looks like. And this one is still crazy crashed. But this one works. Yeah. So what's wrong with this? Why doesn't it look good like the fractal? These numbers are all pretty confusing. And I don't really know what's going on. Is it one of my default values? Is one of the little tiny things I changed changing everything? Or is it a typo? What of the value xt? What's its deal? Xt is equal to the square of cx minus the square of cy plus c real. And then cy is equal to 2 times cx times cy plus c imaginary. Oh, what? It makes that? Oh, that's crazy. What? It looks like a galaxy, everybody. That don't make no sense. Okay, so that's cool. So we figured out what our typo was, and now this looks exactly as we expect. It's a big, freaky fractal. I still don't understand what exactly is in this block, except it's magic that increments the eye in just such a way. If you change it just a little bit, instead you get a weird pattern like a big gray blob, which kind of looks like it came from inside of here. All right, next up, we want to make it animate. That should be easy now that we understand the principles going on. So we'll define a frame value, and that frame will let us keep track of what the phase is of the animation. Let frame equal 0, and every time we draw the fractal, after we're done all of it, we'll say frame plus plus. Now we're going to need to use frame somewhere inside this to kind of push things along just a tiny bit. Where would frame fit in? Frame, 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 frame. Right, of course. So we use frame now. Once we've updated frame, we're going to use it to transform the values C real and C imaginary. I don't know what these numbers are or why they make animation happen. So we'll say C real is equal to its original value, negative 0.8, plus 0.6 times math.sine, and it'll be the sine of whatever the frame is, divided by pi times 20. This makes sense and is easy. And so every time it animates, it should update C real, and something should change. So let's get rid of this and let's put our loop back in. Yeah, it's animating. It's doing some trippy stuff. It's kind of like warping and stuff and changing shape. That's not too exciting. Let's change this to 10 so it animates way the fudge faster. And now we also going to want to update our C imaginary. I don't know why. Equals 0.156 plus 0.4 times math.cos. And these math.cosine calls makes it all a loop. So it just continuously updates in a circle. And we'll say it's the math.cos of the frame divided by 3.14 times 40. So this one's going to have a different, I don't know what you'd call it. A different phase as the top one. Seems to be going a little slow. I think we're overloading it somehow. Do we have console logs in here? Nice, that's pretty cool. So the fractal is animated. What if we make it 1? Will it just crash? Yeah, no, it's going as fast as it can, but if we make I lower, it just gets rid of the color depth. So there's less depth to the color, just flatter. It can only get so bright or so dark. Yeah, I'm not sure why it's slow, but I just assume it's related to the complexity of the code that it's doing. It definitely isn't animating every frame, so we might as well make this every 100. Nice, look at our fractal go. All right, this is looking good. Now the last thing we need to do is add color to it, which should be simple enough because all of our color logic is here magically in this fill style block. So we'll define a palette to hold whatever colors we're using. Let's also get rid of this loop for now, since it is using a lot of processing power. Got myself into a bit of a pickle this time. That is some whack stuff. All right, let's change this to 25 instead of 255. That's going to flatten it out, but also make it work faster. Now, the Fractal guy says to comment this out because we don't need this advanced I to string thing. It actually doesn't seem to have any effect on the drawing when it's changed. So instead of I, the context.fill style will be equal to a palette of I. Whatever the I value is, we're just going to pick the color out of some pre-rendered colors. So now let's make a loop to define the palette. Man, that's nuts. All right, let's just try this. So we'll make a for loop that loops 9 times. And we'll define a color value by taking 31 and multiplying it by x, so anywhere between 0 and 9. And then making it toString 16, which converts it to hex. Let's log whatever that console log is. Right, just makes these hexadecimal codes, which I guess are different colors. That's just a nice little hack. So let's say if color.length is 1, add a 0 in front of it so they're consistent. You can see that top value 0 is just a 0, but should be 0, 0. Content.length equals 1. Color equals 0 and then color. That's looking good. So we'll say palette x, so 0 through 9, is equal to hashtag color 3 times. That makes sense. And no, it's actually color twice and then FF in the last slot. That'll give it a color instead of just a gray tone. Whoa, it's colorful. Nice. Now we'll define a color exactly 8 ahead. So it'll repeat. Once it does the 9 loop, it will stop right before this one that we're going to define. So you say palette x plus 8 is equal to 0, 0, FF color. So that'll just give us another variation on a color based on what we chose. And we get some green going on there. And now for palette plus 17, we are going to make it color 0, 0, 0. And it never quite gets that high. That's because it's got to be a $sign here. Whoa, it's all red, everybody. Whoa. So I guess by fiddling with these numbers, we could get whatever color palette we wanted. be just reds and greens or blues or you name it. So this looks pretty good, actually. Let's clean up all the code we're not using. And lastly, let's set an interval. Draw fractal every 50. Well, folks, it feels pretty good being a master of math and science. We made an animated fractal. We didn't copy and paste any code, though admittedly, I still have little idea what's going on. But I do know that fractals are cool, and I do know that while I don't know everything about them yet, I sure know a lot more than when I began. So that's what I'm hoping as well is the case for you. You know more about fractals than when you started, and also hopefully you just think this is super cool. I think it's cool. Look at it go. It's a big old fractal. And if you change any of these values like C real or C imaginary, it should just change the whole factor. So let's see what happens if we make C imaginary 0.308. It kind of looks the same, but now it's like on an angle. It's just a big trip. Well, that's it, folks. Be sure to check out the link below for a sweet deal on some more learning, and I will see you in the next clip.